Perfect. Okay, so in this tutorial, you guys will see how I can create a basic JFrame slash JPanel program so that you can do very simple drawing, but in addition to that, also include some sort of timer aspect that allows you to animate. So we'll start first by having a runner method, a runner class. All this has is a public static void main method, which allows us to start the entire program. So now let's create our driver. So we can call it a driver, or you can call it your main frame, right? So maybe we'll call it my main panel or something like that. Doesn't really matter what you call it at the end of the day. So the main panel is going to have some sort of constructor. So we'll just have a default constructor. So the default constructor is going to be responsible for creating the JFrame and setting that up. So why don't we do that first? So the assumption is we're going to create a main panel in the runner class. Main panel is equal to new main panel. Right, so that's just how you instantiate an object. When we click play right now, nothing's going to happen because creating a main panel object does nothing, right? It's an empty class essentially. So now let's set up JFrame. Frame of new JFrame. Example drawing. So the constructor for a JFrame can take in a string, which then is responsible for the title bar that you see. In order to make this frame visible, before you do anything else, what you want to do is f.setVisible to true. So that's just a helper method that's part of the JFrame class. The other thing that you really want to do, set the size. Set size. So there's two helper methods to set the size. One takes in a dimension object, then the other one takes in two numbers, which is your width and height, right? Width and height. Finally, what you want to do is you want to set the default action. So default action of X button, right? So the JFrame is going to have your X button and minimize. We want to make sure that when we press the X button, it actually ends the program. Otherwise, you're going to have a whole bunch of running Java programs in the background. And, you know, if your Java program is running some sort of like infinite loop or anything weird, you're going to end up slowing down your computer by a lot. So you want to make sure you do f.set default close operation. And do exit on close. All right, so this should now set up our JFrame. Again, you're setting up the entire JFrame, and then finally the last thing you do is to make it visible. If we go back to the runner class, we know that this is going to create a main panel object. And if we follow the constructor, we know that it should create a JFrame. And so when I click play, it should create a JFrame, and that's what we see here, right? Now, to actually get drawing happening, we actually have to extend the JPanel class. This is because what we want to do is actually override the paint method, which, you know, if you've been in my class, you've seen that a lot when we did Pong, Agario, anything dealing with drawing, really. So what we're going to do up here is we're going to extend the JPanel class. So we want this to inherit from a JPanel. And then, of course, all you have to do is make sure you're importing those things. So when we extend the JPanel class has a paint method. And what we want to do is we really want to override that paint method. I'll give you what the paint method header is. It's public void paint graphics G. Again, if you've been in my class, you should know this. Or you've seen it, I'm sorry. Of course, you want to make sure you're importing the Java libraries that you're using. So now we want to test it out, right? So again, what we want to do is we want to make sure that we can override the paint method because we want to do additional drawing in addition to drawing the JFrame. So I'll just test it out by doing a fill oval at 0, 0, 200 by 200. Now, so since this class itself is a JPanel, right? What we actually have is the object itself creates a JFrame. And so what we actually want to do is we want to add this object, the main panel, into that JFrame. So we're going to go over here and say, add this panel to the JFrame. Allows connection with drawing, right? So that's where we can now make sure that whatever's being displayed on the JFrame, well, since the main panel extends the JPanel, and what we did was we told it how to paint, we would then see the fill oval, which is just a circle in the top left corner of the screen. So we're going to do add this. So the this keyword shows up here because the this keyword references the object that you're currently using, right? So what does that mean? Well, when you create the main panel here, right, what you're doing is you're invoking the constructor, which means you're creating a main panel object. So you're currently in that object that you've just created or you're creating. All right, so I think that's the final connection to make it do the painting. As you can see, right now I've got my drawing here. As a reminder, you can set the color, g.setColor to color.blue, for example. And that should allow you to change the color. Remember to change the color every time before using the drawing tool. So it could be fill oval, it could be draw rect, fill rectangle, fill polygon, etc. All right, so now in terms of animation, how does one incorporate animation into this? That actually adds a lot more complexity, and what we want to do is we want to add a timer. So I'm going to go over here, I'm going to do timer, animation timer. And we have to make sure that we're importing the Java Xwing library, not util. So this is now an instance variable, handles drawing animation. So in order to use the timer, we actually have to give it a method that it's going to continually call, right? The idea is the timer is running, let's say, every 16 milliseconds. And so every 16 milliseconds, you have to tell it what to run. And what we're going to do is we're actually going to implement an action listener, which will give us a method that allows us to pass that to the timer. So all we're doing here is we are importing the we're importing the action listener class, and then what we're doing is we are doing the extra recommended action, which is to implement the action performed. Essentially, action listener represents some sort of behavior, and when we say that we implement an action listener, the class that proposes, the class that says it implements that action listener actually has to implement those behaviors. And that behavior is actually an action performed. So this is going to be what we're going to use as a way to draw. So this method will run. This method is invoked, called by the timer. Okay, so right now we haven't connected that method to the timer itself, so we're going to do that now. So we called it an animation timer. Remember, since we're in the constructor, the job of the constructor is to instantiate the instance variable. As it stands, as you see here right now, this is an instance variable of the main panel class. And so it only makes sense that we're creating that object in here. So what we're passing to this now is the 16 is the interval. So every 16 milliseconds, it's going to invoke the action performed method. So this part is, it says it actually requires an object that behaves like an action listener, which we actually promise that it does, right? So the main panel, because of the fact that we did the implements action listener part, we are now promising to whoever's using a main panel that it implements an action listener. And that just simply means it has the action perform method. Whether or not it behaves in the way that somebody would want to use it, that's a different story. But for us, we're defining what it means to do that. So set up animation timer. Oof, typos. Okay, the last thing we want to do is, well, as it stands, right? So we can start the timer now. So we've created it, now we can start it. But what exactly does it do? Right now, nothing. So if I did some sort of printout like hello world, what do you think you would see? What you should see is that it's going to try to print hello world as quickly as it can, right? Every 16 milliseconds, essentially. So there it is. So depending on your computer, sometimes you do meet that 16 millisecond deadline. So we're going to go ahead and stop it and go back. So rather than printing hello world, obviously that's not what we're trying to accomplish. What we want to accomplish is some sort of animation, right? And so let's say that we're trying to move a ball. What we have right now is just a ball that's stationary. Okay, so if we're trying to move that ball, we have to think in terms of our variables. So if something changes about that ball, it should probably be a variable, right? So again, I'm showing you some pretty bad code right now just to kind of give you an idea of how the animation setup works. And then on your end, you should be working with objects and classes, right? So what you're going to do is you're going to present the ball as a ball object, for example. So here I'm just going to utilize a simple variable x. So if I'm using x here, but then I change x, in theory, the next time paint is called, x would be different, right? So if that is the case, what we should find is, well, if x is updating each time, so if x is going that way each time, then what we should see is that the ball should continue moving to the right. But right now, there's really nothing calling paint over and over, and that's where action perform comes in. So call the frame to refresh. So what we're going to do is we're going to do repaint. So calling repaint just kind of invokes paint over again. So again, if you think about it, we know that the animation timer tries to call action performed every 16 milliseconds. And it says here that action performed is going to call repaint every 16 milliseconds. So that means that X here is being updated, every 16 milliseconds. So therefore, what we should see on the frame is a moving circle. And that's exactly what we have, right? But the only issue that we have right now, and maybe you want this for your code for whatever reason, is the fact that it doesn't refresh the current frame, right? It kind of like draws over the previous frame. And for the most part, you're probably not going to want that. So what you want to do is here, you want to do that g.super. Actually, you want to do super.paint component. And so that's what it's going to do. It's going to refresh the entire JFrame. Super dot. Sorry, it's not the one with the S. It's the one without the S. And, so there you go. So if you wanted to make this move faster, you would then, change the way that X is incrementing. Maybe it's incrementing by 5, for example. And so now what we have is a faster moving ball, right? So again, anything where you have simple geometric shapes drawing, you could use this setup. But what you're going to do is you're going to, of course, use object-oriented programming. Every single object that's on the screen should be represented by the class, right? And then at the end of the day, you want to think in terms of hierarchy and include inheritance. So I'll go ahead and get that going here. So for example, let's say we want to create a ball class. Okay, so now we want to think in terms of, okay, what would the ball represent? So, you know, what are its values? Well, we're going to have private int x and y for location. So typically it's not recommended that you include the instance variables in the same line, but for something as simple as x and y with proper commenting, I don't really care. And then private int width. So here what we want to do is we want the ball to handle its own drawing. So what we first want to do is we want to include a constructor for the ball object, right? For the ball class. So public ball. So essentially, if you create a ball without any specifications of its location, width, and color, what would be the default values? So job of the constructor is to give values to instance variables. And the reason I keep repeating that is because it comes up a lot in the AP exam and on your tests and quizzes, right? So x is equal to 0, y is equal to 0, width is equal to, I don't know, 50, and then c is equal to new color, 50, 50, 50. So 50 red, 50 green, 50 blue. So now, what we also want to do is we want to offload the idea of drawing to the ball. So what we're going to do is we're going to also have a public void paint method similar to the main panel. So this should just literally look like the one from the main panel. So now, rather than doing the work here, right, we want the main panel to see these elements as objects. And so the objects themselves might be keeping track of their own states. So we're going to do g set color to whatever the color of the object is. G.fill oval would be using our x and y followed by our width. And then if you want the ball to be updating, let's say going to the right, then you can do something like this. So again, what we've done now is we encapsulated the idea of a ball into a class, which is again where I want you to be when you're doing your final projects. So ball, b is equal to new ball. So I can create that here, or I can also do it in the constructor, right? So if it's a simple object, you can do it all up here. But when we're separating them and making sure that we know that the constructor of the main panel should set up all those objects, then you can just declare them up here and then instantiate the objects here. So instantiate the rest of the instance variables. Wow. So then here we'll have new ball. Right, remember the job of the constructor is to set up your instance variable. So we see that happening in here as well. So now we know that whenever there's a main panel object that exists, we know that there's a ball object that exists. So now in the paint method, all we have to do is we want to call the objects version of paint. And it turns out that we're just passing along this graphics.g that allows us to call upon those drawing tools. So as you can see, now we can just move however we want, right? But it's all encapsulated in this object called a ball. Ooh, whoops. I should probably lock that in place. So there you go. That's the main setup for drawing related projects, including how you want to start thinking about object-oriented programming.